Simple and compound events are two different types of probabilities, and they're calculated in slightly different fashions. In this lesson, we'll look at some real-world examples of how these two forms of probability are calculated. Again, today's lesson first, probability of a simple event. Second, probability of compound events, brought to you by Thomas Safford. The probability of a simple event. This is the probability of a single event happening. When finding the probability of an event occurring, we'll use the formula number of favorable outcomes over number of total outcomes. After calculating this probability, your answer will need to be in simplest form. Alright, let's look at an example of simple events. Tiny owns a large fish store with many colors of fish. No, not Tiny. Tony. No, not Tiny. Tiny. It's P-O-N-Y. Yeah, there we go. Okay. Anywho, should be right. Tony keeps all of the fish in a large aquarium. In his main aquarium, he has 5 red fish, 6 blue fish, 14 white fish, and 5 green fish. This old gent comes in the market and wants to buy a blue fish to take home. What do you reckon the probability is that Tony will scoop in and pull out a blue fish on his first go? To figure or calculate this probability, Tony needs to determine the total number of fish in his aquarium. Tony needs to add 5 red fish, 6 blue fish, 14 white fish, and 5 green fish, for a total of 30 fish. Tony must also know the number of favorable outcomes. In his tank, there are only 6 blue fish. So, his number of favorable outcomes is 6. The formula to calculate the probability is the number of favorable outcomes over the total number of outcomes. The number of favorable outcomes is 6, and the number of total outcomes is 30. So, the probability of Tony scooping a blue fish on his first go is 6 out of 30. Remember, all fractions must be in simplest form, so 6 over 30 will reduce to, you got it, 1 over 5. Probability that Tony will scoop out a blue fish on his first go is 1 out of 5, or 20%. Alright, probability of compound events. This is the probability of more than one event happening together. Compound events are a bit more complex than simple events in this previous problem. Compound events, they involve the probability of more than one event happening together. With compound events, we'll use the same formula to calculate the probability of each event occurring. To calculate the probability, we'll use the formula number of favorable outcomes over the number of total outcomes. Once we find the probability of each event occurring, we will multiply these probabilities together. It's like this. Have a seat. Take the probability of one event and multiply it by the probability of a second event. So we have event 1, and we have the number of favorable outcomes over the number of total outcomes, and then we're going to multiply it by event 2. Alright, let's look at the example. So here's an example. Wendy lives in Kyle. No, not Kyle. Kyle. Ah, bloody yank. Kyle. C-A-R-L. Back at it. Wendy lives in Kyle playing a board game. It's Wendy's turn, and she needs to roll 2 dice and get both to land on 6 to be the victor. What's the probability that Wendy will roll 6 and then roll another 6? Right. To solve the problem, we need to calculate each event separately. The total number of outcomes on the die is 6. And the number of favorable outcomes is 1. Because there's only one 6 on a die. Now, probability of Windy throwing a 6 on her first go is 1 out of 6. Next, we need to calculate the probability of Windy getting a 6 on her second go. Since these dice are the same, the probability of getting 6 on the second will be 1 out of 6. Now we know the probability of both events happening. We need to multiply these two fractions together. So, event 1, 1 over 6. Event 2, 1 over 6. Multiply them together. And you got it. 1/36. So the probability of Windy rolling dice and getting a 6 on both is 1/36. What are we going to do with this? Well, now that you understand the probability of simple and compound events, we can apply it to genetics.